Hello, Professor. My name is Rupinder Kaur, and my partner name is Jashanpreet Kaur, and we are presenting the extraction and the purification of the protein from the baker's yeast. Now here is the tables of content. First we talk about the introduction. In the introduction, we are talking about the background of the cytochrome C, then the structure of the cytochrome C and its function, and most importantly its isoelectric point and the polarity of the cytochrome C. So this all comes in the introduction part. Then we are next further going to the significance of the extraction. First we talk about the different methods using for the extraction of protein, and then why we need to extract the protein, the need for that extraction, and further we are discussing the purpose of the protein extraction. So this all comes in the significance of the protein extraction. Then we are talking about the results taken from the different steps, and then further we are discussing our results in the discussion section. After that we are giving some references for from where we are collecting the data. Introduction about the cytochrome C. Cytochrome C is a small heme protein located in the inner membrane of the mitochondria. It plays a vital role in the cell apoptosis as well as respiratory electron transport chain. It can undergo oxidation and reduction reaction due to its iron, and that iron converts into ferrous and ferric form. In the electron transportation, the electron is transported from complex 3 to complex 4. And if I talk about the apoptosis, it starts the process of apoptosis and then it binds to the apoptotic protease activation factor 1, means APAF1, and it is it is also catalyzes several reactions like hydroxylations, and it is a basic protein, which means the pi of the cytochrome C is 9.6 and has a positive charge on it, and it is a water soluble protein, which means it can be soluble in the water, and that heme, and it also contain a heme as a cofactor. In this slide, we are talking about the extraction of the protein. There are different methods which are used to extract the protein. And after that, we are talking about the significance of the extraction of the protein. So in the extraction of the protein, 7 different methods are involved. First is lysis of the yeast cell. Second is washing. Third, elision of the cytochrome C. Fourth one is protein precipitation with the ammonium sulfate. Fifth, cation exchange chromatography. Sixth is protein characterization by the UV visible and the Bradford assay. And the last is STS page. So for the protein extraction, first we need to lysis the yeast cell. Yeast means Saccharomyces cerevisiae. It contains the cytochrome C. So for that, we lyse the Saccharomyces cerevisiae cell in the yeast. So to lysis that cells, we using the electric blender, and after that we wash that. For the washing, we are using the Biorex 70. So Biorex 70 is a weak cation exchange which is used for the washing. It is used to purification and the fractional of the peptides present in the protein, and it contains the carboxylic acid to exchange the groups for the macromolecules acyclic polymer lattice, which is its arrangement. So it maintains for the washing we are maintaining the pH 8.4. It is very essential to make sure that the pH should be 8.4 because it's a running the pH 8.4 provides the running conditions, and the maximum of the negative charge are present in the pH at that pH, and it also ensures the cytochrome C is positively charged so it can easily washed away, and because that the pi of the cytochrome C is less, so it is easy to elute the cytochrome C. So after washing the cytochrome C with the help of Biorex 70, now we need to elute that cytochrome C. So for that elution, we using the plastic chromatography column. In the plastic chromatography column, we put the we put the Biorex as a stationary phase, and then we put our cytochrome C. In that, we elute only the cytochrome C. After that, we are forwarding towards the fourth step, which is known as protein precipitation with the ammonium sulfate. So we need to precipitate that cytochrome C in the pure form. For that, we need to use this ammonium sulfate or any salt. So basically, the solubility of the protein is depend on in its ionic strength and the concentration of the salt. The concentration of the salt is very important. For that, there is two different methods, salting in and salting out. For the precipitation, we using the salting out technique. The solid the solubility of the protein is increased with as increased the concentration of the salt increases. At the low concentration, the protein cannot soluble. So this is known as salting in. In the salting in the salting out process, at a sufficient high ionic strength, the protein solubility is decreases at that point where the protein get completely precipitate. For at the high ionic strength, the protein is going to be completely precipitate as we want that. So in our practical, we are unable to use the salting out process because we have very low concentration for our cytochrome C, and for that we are precipitating by contaminated the protein, and then we are adding the ammonium sulfate. The concentration of the ammonium sulfate, it should be 85%, and after that putting a formula we get the exact concentration what we need. So here we are extracting the so now we done with the precipitation of the protein. Now we can move for the further steps. The next step in the extraction of the protein is cation exchange chromatography. We can separate we can separate the cytochrome C with other substances. The cytochrome C has a positive charge on it. Due to that, it is very easy to separate it on the basis of the charge. However, for that, ion exchange chromatography is a method which is ion exchange chromatography is a method which separates the things on the basis of their charge. For here we are using the cation exchange chromatography, one of the type of the ion exchange that has a reversibly bind molecules to immobilized charged groups. So it is useful to separate the macromolecules, and purposes we for the purification purposes. Due to these properties, we are using the cation exchange chromatography in the extraction of protein to purify the protein. It has basically four steps to do. First, the molecules bind in an appropriate way by creating the equilibrium in the exchanger buffer. That means that for the exchanger buffer, we create the equilibrium. On that position, the molecules which are bind appropriately that we can elute in very nice way. Second, the solute molecules have an opposite charge to the buffer, and due to that they can easily bind to the gel. That is also a second advantage for the extraction of the protein. And third, the unwanted molecules which cannot easily stick to the gel, they can elute very easily. For the illusion with the salt increase the ionic strength of the protein. Here we are using the NaCl, sorry, and here we are using the salt to increase the ionic strength of the cytochrome C. And and lastly, they are also unwanted molecules which are tightly stick to the gel. These molecules are very hard to elute because they are very tightly sticky to the gel. For that, the ionic strength of the protein is already increased. So due to that, that tightly unwanted molecules eluted very easily. So after eluding the protein from by using the an ion exchange chromatography, next we are moving further for the characterization and the quantification of the extracted protein. For the protein has the ability to absorb light at some wavelength. So in the presence of UV region, protein is easily absorbs the light, and that absorption is advantage in that to characterize the protein. We are using the UV absorbance method to determine the concentration of the any substance. So here we are using the same method to determine the concentration of the protein. And, and to analyze the quantification of the protein, we use the Bradford assay method. This method is basically based on the Beer's law. Beer's law states that the absorbance is directly proportional to the concentration of the protein, and in this the absorptivity is constant. At a given wavelength, we can check the absorbance of the protein, and by taking the absorbance on a particular wavelength, we can find out the concentration of the protein. For determine the concentration of the protein, we plot the graph against absorbance against we plot the graph against absorbance against the concentration by using the standard curve. So we can determine our unknown, that is we can determine the concentration of our unknown protein. So the last step in the extraction of the protein is SDS page. So SDS page is a sodium rudactyl sulfate polyacrylamide gel electrophoresis. So in this, the ions of the same charge are placed against the opposite charge medium, and for this the smaller ions of the same charge are moved fast towards the electrodes, and the process of this movement is known as the electrophoresis. So we are using it here is page. So the gel is made up of the copolymerization of acrylamide gel and cross-linked with the methyl molecules. So this is known as polyacrylamide gel. So it is very useful to determine the molecular weight of the protein, its purity, and its homogeneity. It is also helpful to determining the isoelectric point of the protein. Well, the separation of the protein on its native condition is very hard. So the electrophoresis is a good option to separate the protein. So here we are using the SDS, the sodium rudactyl sulfate. It is the ionic detergent which is strongly binds to our protein and helps to separate the protein. So in this, we inoculate our protein sample into the gel, and then we put it in the buffer and attach to the electricity. After 1.5 hours, the distance traveled by the protein from the gel well can help to estimate the size of the protein, structure of the protein, and the degree of the complexity of the protein. So this is very helpful to determine the protein size, shape, and other factors. So in this experiment, we stain our protein sample due to easy visualization. So the stain we are using here is comessive blue, and it is very helpful to identify the protein. So these all are the 7 steps which involves in the extraction of the protein. After we are discussing about its results.
Hello Professor, my name is Jashanpreet Kaur and today I'm here to present our rest of the slides. So talking about the results, starting with resin elution. The picture is showing the crude cytochrome C which is extracted from the baker's yeast using a plastic chromatography column. The pink color of the cytochrome C is due to the presence of heme group, which occurs due to the action of elution buffer, that is NaCl and sodium phosphate. It initially helps to remove unbounded protein before releasing the protein of interest. Resin elution is followed by precipitation of protein with ammonium sulfate. So to calculate the mass of ammonium sulfate used to precipitate out the protein, we use the given chemical formula, that is mass of ammonium sulfate is equals to volume of cytochrome C extract in ml into 0.559 gram per ml. So the volume of cytochrome C that is extracted in the tube is 4.2 ml, and to achieve a saturation 85% saturation at 0 degrees, 0.559 gram per ml of ammonium sulfate is used. So putting all these values in the formula, the mass of ammonium sulfate that we got is 2.3 gram. In this slide, we will calculate the mass of precipitate. So to calculate the mass of precipitate, first of all, the weight of empty tube was taken, that is 6.79 gram, followed by weight of tube plus precipitate, that is 7.138 gram. So the mass of the precipitate is calculated as 0.348 gram. The given pictures show the experimental setup for the cation exchange chromatography for the purification of protein. It has two reservoirs, reservoir 1 and reservoir 2. Both are connected to each other, and the reservoir 2 is connected to the chromatography column. The pink band in the column represents the pure cytochrome C extract, which is extracted by using concentrated solution of sodium chloride and phosphate buffer, which is used to wash out the closely packed substance. And it is given that the protein with low pi value eluted faster as compared to the protein with high pi value. Table 1 shows the absorbance of extracted protein in UV visible spectroscopy at 280 nm and 416 nm. So the wavelength range 280 nm is used to determine the presence of proteins, whereas at 416 nm the existence of cytochrome C is observed. And the tube number 2 is having a highest absorbance value, that is 1.8904 at wavelength 416 nm. Protein characterization and quantification by UV-Vis Bradford assay. So the table 2 shows the absorbance at 595 nm of the standards with different concentrations. All the standards were taken and their concentration was taken at the same wavelength, that is 595 nm, and a graph is plotted between absorbance versus concentration. Determination of concentration of protein extracted using equation from the graph plotted for Bradford's assay. So by substituting the absorbance value of the protein obtained with the y-axis, the values is found to be 4.07 milligram per ml. That is the concentration of protein extracted. So now calculating the total protein yield and absorption coefficient. To calculate that, the given formula was used, that is C is equals to A divided by AB, where C is the concentration of the protein in mole per liter and A is the absorbance at 416 nm. The small a is absorption coefficient at 416 nm, whereas the B is the path length, that is 1 centimeter. So putting all these values in the formula, we got 14.64 mole per liter, that is the total protein yield. And the protein quantification, that is Q is equals to absorbance at 260 nm and divided by absorbance at 280 nm, and the ratio is 0.4. STS phase result. The picture number 1 is showing the sample for gel, and the picture number 2 shows the results for the STS phase of our group. The well number 1 and 6 were having bladder, whereas the well number 9 contained crude cytochrome C and the well number contained filtered cytochrome C. The band in our gel is visible, which is due to improper running of the gel, that might be due to the improper supply of power. The table number 4 shows the molecular weight of the protein along with the distance traveled and the log value of the molecular weight. So, A graph is plotted between the log value of molecular weight and the distance traveled in centimeter. It is a straight line graph, and this is used to calculate the molecular weight of our extracted cytochrome C. Now moving to the discussion part. Overall, this experiment is based on the extraction and purification of cytochrome C from the baker's yeast, so which includes various steps, that is cell lysis, washing and elution of the resin, and precipitation of ammonium with aluminium sulfate, and so on. So in this experiment, the concentration of cytochrome C by Bradford's method is calculated as 4.07 mg per ml, and the concentration of cytochrome C calculated by spectrometry is supposed to be 14.64 mole per liter. So, and the pure protein Q factor, that is ratio of absorbance at 260 nm with absorbance at 280 nm, is 0.4, which is supposed to be zero point 0.6, 0.6 in every case, and the molecular weight of cytochrome C is supposed to be in between 100 and 150 kilodalton. Talking about the errors that could be occur during the experiment, that is, the errors can be occur while maintaining the pH of the resin. The fingerprints on the cuvettes can also be a cause of experimental error. So the impurities in the extracted cytochrome C may be due to the improper technique, such as washing of the resin. So here are some improvements for the experiment. First of all the cuvettes must be cleaned properly using Kim wipes to avoid any experimental errors during the absorbance. And moreover, the top of the column bed shouldn't be dry at all. So there is always a thin layer over the top of the column. Moreover, carefully decant the cloudy liquid, avoiding the resin while washing it. So here are some references from where we have chosen the material for our experiment. Thank you for watching.